Dear students, in the last class we studied about different types of polynomials. What is quadratic polynomial? What is cubic polynomial? We have studied about these things, right? Today we are going to study about the relationship between the zeros of a polynomial and the coefficients of the polynomial. First of all, let me tell you what was a quadratic polynomial? A polynomial whose degree is 2, right? So there is a general form in which we have to mention any polynomial. It may be quadratic, it may be cubic, it may be biquadratic. The general form is like this. Whenever you are getting a polynomial, you can understand the degree of the polynomial. That means you can name the polynomial. You can categorize them as cubic polynomial or quadratic polynomial. That's the two topics which we are going to deal with in this chapter. So when you are getting a polynomial, it may be either a quadratic polynomial or it can be a cubic polynomial. But when you are getting so-called polynomial, first of all, what you have to check? First of all, what you have to check means you have to make sure that it is in the order of the standard form. So now what is the standard form? The standard form of expressing any quadratic polynomial is ax square plus bx plus c. That means first of all you have to say where a, b and c are integers. So first of all, when you are expressing them, they should be of the term x square. Then it should be of the term x. Then there should be a constant that's equal to 0. That will become an equation itself. So this is the way, means that's the way how to mention them. First of all, you have to write the biggest power. Means if it is a quadratic, the biggest power will be x square itself, right? So something x square, something x, then a constant number. So in general we will say ax square plus bx plus c. That is the general form how to express a quadratic polynomial. Then what will be the general form of a cubic polynomial? Definitely, just as you thought, the first term will be cube of x, right? So we can define it as ax cube plus bx square, right? Ax cube plus bx square plus cx plus d, where a, b, c and d are integers. Clear? So this is the way how to express a given polynomial in the standard form. So if whenever you are getting a question, the first thing which you have to check is whether the given polynomial or the question which is given in front of you is in the standard form. If it is not in the standard form, forget not to bring it in the standard form, then only start doing. Because plenty of times we have seen that plenty of students, they make a mistake. Even though they know the equations, they know how to deal with these things. But just because of this carelessness, they will lose the points. So that's why to remind you again, whenever you are getting a polynomial, you have to check whether it is in the standard form. If it is not in the standard form, you have to make it, or you have to convert it, or you have to arrange it in the standard form. Clear? Now, what is the relationship between zeros of any given polynomial and the coefficients? Coefficients means the number which lies just in front of the given variables. That means in front of x square there is a variable, in front of x there will be another variable, right? So finally you can see there will be a constant term regarding quadratic polynomial. So these terms or that numbers are what we call exactly coefficients. Keep in your mind, whatever numbers you are seeing inside that one, all the numbers are together called the coefficients of x or x square. Where it lies, it depends upon. If the number is in front of x square, it will be the coefficient of x square. If that number is in front of x, that will be the coefficient of x. If it is simply a number without x, that's what we call a constant term. Okay, so keep this in your mind. Now, is there any relationship between the zeros and these coefficients? Yes, there is. That's what we are going to study today. In our last topic, we discussed how to find a zero of a polynomial. How to find a zero of a polynomial? If a polynomial is given, first of all, you have to equate it to 0. If a polynomial is given, just imagine ax square plus bx plus c is equal to 0. A polynomial is given. An equation is given. And this quadratic equation, if you want to find the 0 of this equation, you have to equate it to 0 and then you have to solve for that x. And that x which you get is called as the 0 of the polynomial. Whenever you are solving, especially a polynomial, when you are solving a polynomial, we will never say the solution of a polynomial. Rather, we will use this word 0 of a polynomial. It's also called roots of a polynomial. So in some textbooks, they may be given as zeros of a polynomial, whereas in some textbooks, they will mention as roots of a polynomial. So keep this in mind. Both of them are same. It just gives you the clear-cut point that is the solution of the given equation. That's the only meaning of that one, but we are not using the term. We are using the term 0 of an equation. Okay, keep this in mind. Now, if you're finding a 0 of a quadratic polynomial, that means if you're finding the solution for a quadratic equation, I already told you, as the degree is 2, so came the name quadratic, right? So if the degree is 2, what does it mean? They are having 2 zeros. They are having 2 zeros. That's the meaning of that one. So now, let us imagine that let alpha and beta be the roots of the given quadratic equation. If any quadratic equation is given, just imagine that alpha and beta are the roots of the given polynomial. Okay. If alpha and beta are the roots of the polynomial, say while solving for x, you got alpha, then you got one beta. Just we are imagining two numbers. It's already alpha and beta are Greek alphabets. We are simply using here for our simplicity just to understand the theorem behind this one. Okay, nothing more. It's alpha and beta. So if alpha and beta are the roots of the given equation, or if alpha and beta are the zeros of the given polynomial, then we can say the sum of the roots, that means alpha plus beta, will be always equal to minus b by a. Minus b. What is minus b? Minus of b. What is b? What is b? B is the coefficient of x, right? So we can mention like this also, minus of coefficient of x divided by coefficient of x square, that is minus b by a. So that is the relationship. So again I repeat, alpha plus beta is equal to minus b by a, or sum of the roots or sum of the zeros is equal to minus b by a is the first relation. Second relation, the product of the roots. What were the roots? Alpha and beta. So product of the roots means alpha into beta, right? Alpha multiplied by beta. So alpha beta is equal to c by a. What is c? C is the constant term, right? C by a. C by a. So c is the constant term. A, what is a? A is the coefficient of x square. So we can say like this, the product of the roots is equal to constant term divided by what is a? Coefficient of x square. So we can mention like that also, okay? So alpha plus beta is equal to minus b by a, that is the first relation. And the second relation means alpha beta is equal to c by a. And now this is much more important. Just keep this very firmly in your mind, okay? See, if alpha and beta are the roots of equation, right now we studied that the sum of roots are having a relationship with the coefficients, and the product of roots are also having a relationship with the coefficient. That means if a polynomial is given, you can find the sum of roots. You can find the product of roots, right? Just by taking minus b by a, you will get the sum of the roots. If you are taking c by a, you will get the product of roots. Now, what if the sum of roots is already given and the product of roots is also given, and how can you find a polynomial from this one? Means the sum of roots of a quadratic polynomial is given, the product of roots of a quadratic polynomial is given, and from these zeros, is there any way to find back what the exact polynomial is? Yes, there is. This is an important equation. If the sum of the zeros are given and if the product of zeros are given, then the polynomial, that means the quadratic polynomial p of x, that means it will be an x, is equal to x square minus alpha plus beta, that means x square minus sum of the roots multiplied by x plus alpha beta, that means product of the roots. That means if the sum of roots are given and if the product of roots are given, easily you can find the polynomial itself. So this thing you should keep in your mind. Okay, that's very important regarding quadratic polynomial. And regarding a cubic polynomial, the general form of a cubic polynomial is ax cube plus bx square plus cx plus d is equal to 0. There also we can say there is a relationship between the zeros and the coefficient of a cubic polynomial. There we will write like this: the sum of the zeros of cubic polynomial. That means there are 3 zeros, right? Because it's a cubic polynomial. So alpha and beta is not enough. We have to take one more letter. So we will say let alpha, beta and gamma be the zeros of a cubic polynomial. So that alpha plus beta plus gamma, that means sum of the roots, is equal to again minus b by a itself. But here note it on minus b, that means it is not what of that which we have taken in quadratic. It's different because now it is cubic. So minus b by a. So here we will write it is minus of, here what is b? It is the coefficient of x square. And what is a? It is the coefficient of x cube because it's cubic polynomial. So we can say like this: alpha plus beta plus gamma is equal to minus b by a. That's about sum of the roots. What about product of the roots? Product of the root means alpha, beta, gamma. Alpha into beta into gamma is equal to minus d by a. What is minus d? Minus of the constant term divided by the coefficient of x cube. That is product of roots. Third one more thing is there: alpha beta plus beta gamma plus gamma alpha is equal to, means sum of the roots, means if you're taking two zeros and if you're adding them and taking the whole sum, alpha beta then plus beta gamma plus gamma alpha is equal to c by a. So in quadratic there were only 2 things which we have to remember: sum of the zeros and product of the zeros. Here there are 3 things. It's a cubic polynomial too. And now the another thing is that if a cubic polynomial is given, keep in your mind there will be 3 zeros. There will be 3 zeros. And if a quadratic polynomial is given, there will be only 2 zeros. And this is the relationship between the given zeros of a polynomial and their coefficients. Now let us get into the next exercise and let us do some sums so that you can understand this theory very fast. Exercise 2.2, the very first question. Check out the question. What is the heading? Read the heading here. Find the zeros of the given polynomial and verify the relationship between zeros of the polynomial and their coefficients. That means first of all you have to find the zero. Okay, that's what the question means. First of all you have to find the zero. After finding the zero, what you have to do? You have to find you have to verify the relationship. I already told you what was the relationship. Alpha plus beta is equal to minus b by a. First relationship. Second one, alpha beta is equal to c by a. The second relationship. So these 2 relationships you have to verify. You have to check it whether it is right or wrong. Okay, that's the verification. So 2 things. So number 1, we have to find the zero. So let us do the very first question. Let us find the zero. How to find the zero of a given polynomial? Here what is the polynomial? Come on. X square minus 2x minus 8. That's the polynomial. Very clearly you understand that this is a quadratic polynomial. You are right. It's a quadratic polynomial because you can see the degree is given as 2 itself. So if you want to find the zero of this equation, what you have to do? You have to equate it to 0. So we will write x square minus 2x minus 8 is equal to 0. Now how to simplify this one? You have studied in your 9th class. Okay, check out the videos of 9th class so that you can understand very fast how to factorize this one. Okay, but again let's explain in this chapter again once more. It's by splitting the middle terms. How to split the middle terms? Before splitting the middle terms, you have to choose 2 numbers. Means here what is the middle term? Here it is minus 2x, right? Minus 2x is the middle term. So you have to split minus 2x. You can split minus 2x by numerous numbers, but it may not be sufficient for you to get a solution for this quadratic. So if you want to select 2 numbers, you have to select the very accurate numbers and the very apt numbers. And now listen to me, how to select this number. This is a very important point. Now inside this given quadratic, what is the quadratic equation given here? The first term is x square, the second term is minus 2x, and the third term is minus 8. Clear? Check out the last term, I mean the constant term. It is minus 8, I mean 8, simply 8. Just think about the digit 8 itself. What is the coefficient of the x square? Coefficient of x square is 1, right? Because in front of x square nothing is written, that means it is 1. 1 multiplied by this 8, how much it is? 8. Now factorize this 8. What you will get? 1 into 8 are 8. 1 into 8 is equal to 8. Okay. Then another one, 2 4s are 8. 2 into 4 is also 8. That means 1 and 8. It's a set 1, 8. It can be 1 or 8. Second set 2 and 4, because 2 4s are 8. 2 and 4. Among these two sets, any one set only we will have to take it as the splitting. Means when we are going to split the middle term, we will use, among these two sets, we will use only one set. It may be 1 and 8, or it can be 2 and 4. How to choose the exact set? I will tell you. See, here check out the sign of the constant term. What is the sign of the constant term? It is minus, right? Minus 8. That means minus is the sign of the constant term. That means while minusing these two numbers, you have to get the center term. What is the center term here? It is 2. Okay, it is 2. So while subtracting these two numbers, you have to get 2 as the answer. Tell me, what about the first set? It is 1 and 8. If you are subtracting 1 and 8, will you get 2? Never. Because you know 1 and 8, when you are subtracting them, you will get 7 itself. So that is not the set. Then come to the second set. What about second set? 2 and 4. Now 2 and 4, what is the difference of 2 and 4? It's 2 itself. So we are going to use this 2 and 4. Okay. So instead of this middle term, we will copy down the first term as it is. We will copy down the last term as it is. But in this middle term, we are going to split this middle term. Means we are going to substitute this minus 2x. What are the numbers which we selected? It is 4 and 2. Now the next thing is you have to think about the sign. Which sign should be allotted to 4 and 2? Just to think this one also, again you have to look on the constant term. What is the sign of the constant term? If the sign of the constant term is minus, if it's a negative sign, it means that both of them are having different signs. Means if one is positive, then the other should be negative. And if the last term is positive, that means both of them should have the same sign. It may be negative sign, it can be positive sign also. Means both of them can be positive and both of them can be negative. The only condition is they must have the same sign. Is that clear? Okay. Now here anyhow the last term, it is negative. So that means both of them are having different sign. Now my question is whether if you are giving a positive sign to 4, then you have to give negative sign to 2. And if you are giving a negative sign to 4, then you have to give a positive sign to 2. Now our question is, which sign will we give to a particular number? Which sign we will give to 4? Which sign we will give to 2? How to choose that one? Check out the center term. Here what is the center term? Center term is 2x. What is the sign of center term? It is minus. So this same sign you have to give to the bigger number. Which is the bigger number among these two things? Among 4 and 2. In between this 4 and 2, which is the bigger number? 4 is the bigger number. So to that bigger number, you will have to give the sign of the center term. Here the center term is minus, and that's why you will give that minus to 4. Now what does it become? Minus 4x. So if it is minus 4, then automatically I told you both of them must have different signs. If it is minus, then 2 will be positive. So 4x, that means minus 4x, and 2x will be the terms which we are going to take in the center term. So now let us split the center term. Splitting the center term, you will get x square plus 2x minus 4x minus 8 is equal to 0. Right? Now keenly watch these terms. You can see that in the first two terms, what is common? X is common. Bring it out. So you write x into, within the brackets, x plus 2, because already you have taken x outside. Now what about the other two terms? It is minus 4x and minus 8. What is common there? Minus 4 is common. Bring it out. So taking it out, minus 4 within brackets, again you will get x plus 2. Right? Because already minus you have taken out. So you will get minus 2 itself. That is equal to 0. Now see these two terms. In these two terms, you can see that x plus 2 and x plus 2 is common. Bring it out. So now if you are taking that common outside, x plus 2 if you are taking outside, then what it will become? X plus 2 into, you took x plus 2 outside. Now x plus 2 into, what is the remaining part? In the first point, x is remaining. In the second part, minus 4 is remaining. So x minus 4 within the second bracket. Now you got x plus 2 into x minus 4 is equal to 0. So students, here you can see that the product of two numbers is 0. What does it mean by product of two numbers is 0? That means if the product of two numbers is 0, it clearly means that in these two numbers, one number should be 0, right? Then only you will get the product as 0. So here what did you got? X plus 2 into x minus 4 is equal to 0. X plus 2 into x minus 4 is equal to 0. That means we can say x plus 2 is equal to 0 or x minus 4 is equal to 0. So if x plus 2 is equal to 0, what will be the value of x? X will be equal to minus 2. And if x minus 4 is equal to 0, then x will be equal to plus 4. So you got two roots. What are the roots right now? You got minus 2 and 4. So we will say here alpha is equal to minus 2 and beta is equal to 4. You got alpha and beta. Now let us verify the roots, right? Let us verify the relationship between the zeros and the coefficients. First of all, sum of the roots. That means alpha plus beta is equal to, here what is your alpha? It is minus 2. What is your beta? It is 4. So minus 2 plus 4, how much? It is 2 itself, right? 2. Let us verify whether it is minus b by a, because we already know that alpha plus beta should be equal to minus b by a. Now already when you are adding this original alpha and beta, the answers which you got right now, when you simply added them, you got the answer as 2. Let us check it whether it is minus b by a. Here what is the value of b? B, what is b? It is the coefficient of x. So here the coefficient of x is minus 2. So minus b means minus of b. So minus of minus 2, that means plus 2, divided by, what is the a here? It should be the coefficient of x square. Here the coefficient of x square is 1 itself. So we can say 2 by 1, right? It's minus b by a. So it's verified. Now let us check the product of roots. What is product of roots? It is alpha beta, right? So alpha beta is equal to, here what is alpha? It is minus 2, and what is beta? It is 4. Minus 2 into 4, how much it is? Minus 8. Let us check whether it is c by a, because already we know alpha beta is c by a. Let us check it. What is c here? Look out. You can see it is minus 8. What is a here? It is 1 itself. So minus 8 by 1, how much it will be? Minus 8 itself. Yeah, that's also verified. That means you not only found the zeros of the given polynomial, you found that the relationship between the zeros and the coefficient are also exactly the same. That means you have found the correct zeros, means your answer is true. Going to the second question. 4s square minus 4s plus 1 is equal to 0. So here it is a polynomial in S. It is P of S, right? A polynomial in S. So if you want to find the 0, as usual, you have to equate it to 0. So we will write 4s square minus 4s plus 1 is equal to 0. Now, what is the coefficient of s square? Means the very first coefficient, that means the a. That means our a. What is the a here? It is 4. What is the c here? That means the constant term, it is 1. 4 into 1, it is 4. Now factorize 4, because anyhow we have to split the middle term, right? That's why we are doing all these things. So factorize 4. What you will get? 1 into 4 or 2 into 2. That's also 4. So there are two sets. One is 1, 4. Another one is 2, 2. Now, how should we select this one? I told you, check out the sign of the last term. I mean, the sign of the constant term. Here our constant term is, plus 1. So the sign is plus. That means while adding these two numbers, you have to get the middle term. Here the middle term is 4. So here 1 plus 4, how much it is? It is 5. That's not equal to the middle term. Another set is 2 and 2. 2 plus 2, that is 4. So we got the numbers. What are the numbers? 2 and 2. Now let us think about, so the numbers will be 2s and 2s, okay? The numbers will be 2s and 2s. Keep this in your mind. Now let us think about the signs of these two numbers. What about the signs? Now again we have to focus on the constant term. What is the constant term? It is plus 1, plus 1. As the constant term is positive, we can come to the conclusion that both of them will have the same sign. It can be either negative, it can be either positive. Now, whether we want to give positive or whether we want to give negative, check out the center term sign. The sign of the center term. What is the sign of the center term? It is minus 4s. That means the sign of the center term is negative. That means both of them, as we already know that both of them, they must have the same sign, and as the center term is negative, we will give the negative sign to both of the terms, and these terms will become minus 2s and minus 2s. So we are going to split the middle term by minus 2s, minus 2s. Let's split. Come on. What will be the next step? 4s square minus 2s plus 1 is equal to 0. From the first two terms, what is common? Take it out. Here what is common? 2s is common. When you're taking 2s outside, you will get within brackets 2s minus 1, right? Then what about the other two terms? It is minus 2s and plus 1. From this one, nothing is there common. When you're seeing at a glance, nothing is there common. So if there is nothing common, bring 1 outside. Anyhow, the initial point is minus 2. So I'm taking minus 1 outside. If you're bringing minus 1 outside, within brackets, what will be left over? It is 2s, then from plus 1, already you took one minus 1. So minus 1 will be there. Minus 1, because this minus 1 into this minus 1 will become plus 1 itself. That's the thing which you have to keep in your mind. Close the bracket is equal to 0. Now check out the terms within these brackets. They're exactly the same, right? So take it out. Now 2s minus 1 is the common term. So bring it out. 2s minus 1 within one bracket. So the rest of the terms will be in the other bracket. What are the rest of the other terms? It is 2s from the first term minus 1 from the second term. So 2s minus 1. Oh, see here, 2s minus 1 into 2s minus 1 is equal to 0. That means either this 2s minus 1 will be 0 or this 2s minus 1 will be 0. Both of them are anyhow same itself, right? So we write 2s minus 1 is equal to 0, or again 2s minus 1 is equal to 0. That is 2s is equal to 1. That means s is equal to 1 by 2. There also you will get s is equal to 1 by 2. So you got two roots. That means two zeros. That means alpha and beta. Here the alpha is 1 by 2. Beta is also 1 by 2. Now let us start verifying, right? Okay, let's start it. How will you verify? Come on. Alpha plus beta. So here what is alpha? It is 1 by 2. What is your beta? That's also 1 by 2. So 1 by 2 plus 1 by 2. How much it is? There is no need to divide actually, right? Just to find the LCM and do this thing, that thing. There's no need, because half plus half, full, right? That means 1 by 2 plus 1 by 2, that's equal to 1 itself. Half and half, when you're adding together, you will get 1 as the answer. That's it. Or if you're going to find the LCM and doing, you can do it like that. But you will get 2 by 2 after plenty of steps. So rather than going into that one, you can simply add them together. Half plus half is equal to 1. You can conclude like that. So now you got as sum of the roots is equal to 1. Let us check whether it is equal to minus b by a. What about our b here? What is our b here? It is minus 4. It is the coefficient of x. It is minus 4. So minus of minus 4 means minus of minus 4 is plus 4. So plus 4 divided by, what is a? The coefficient of x square. What is that one? That's also 4. So 4 by 4. What is 4 by 4? 1 itself. So it's verified. What about alpha beta? Here alpha is equal to 1 by 2 and beta is also equal to 1 by 2. So we can write alpha beta is equal to 1 by 2 into 1 by 2. That is equal to 1 by 4. You got 1 by 4. The product of the zeros is 1 by 4. Let us verify whether it is same. What was the product of zeros? It is c by a. Here what is our c? Check it out. It is 1. What is our a? It is 4. So 1 by 4. Yeah, it's verified. So this is how you have to verify whether you got the correct thing. Means whether you got the correct zeros. This is how you have to verify that one. Okay.